Welcome back to another Physics in the Flesh episode, Standing Waves and Resonance 2. A particular guitar string is supposed to vibrate at 200 Hz, but it is measured to vibrate at 206 Hz. By what percent should the tension in the string be changed to correct the frequency? So what we need in this problem is a relationship between frequency and tension, and that's not going to come from one formula. In fact, we're going to be using the two formulas that we saw back in video 141, the exact same two. We're just going to work with them a little bit differently. Okay, so we're going to start off with the expression for frequency. Okay, the frequency of a string is equal to NV over 2L, where L is the length of vibration, V is the speed of the vibration. Okay, now I want to take out the N over 2L because for one vibration, these are constant, right? The speed can always change, but this right here, this is constant for the same string. Okay, so therefore I can actually state that the frequency is proportional to the speed on the string. Okay, that's the first formula that I want to take a look at. The second is an expression for speed. Okay, so we also saw in video 141 that the speed on a string is equal to the square root of the tension divided by the linear mass density, or mass over length. Okay, now it's a similar idea here. Mass over length, the linear mass density, is also going to be constant for the same string. So in essence, what you have here is that V is proportional just to the square root of the tension, because that's always going to stay the same. So if V is proportional to the square root of the force of tension and frequency is proportional to the square root of V, then by the power of mathematics, therefore the frequency must also be proportional to the square root of the tension. And that's our relationship right there. Okay, so here's the thing. We know that right now we're vibrating at 200 Hertz. We need to be at, we're at 206. We need to be at 200 Hertz. So what we're going to be doing here is a ratio. The frequency that I'm at now versus where I need to be. So I'm going to do the square root of ft2 over the square root of ft1. Okay? And that's going to be proportional to f2 over f1 via this relationship. Okay, so because I want to know the ratio of the tension forces, I'm going to square both sides just to get rid of that square root. So square this side, square that side, and you're going to just get ft2 over ft1 is equal to f2 over f1 squared. Now I wouldn't distribute the square onto the fraction there, because whatever you plug in for the frequencies, you don't want to have to square each one individually and then deal with them later. Okay, so let's just leave it like this. So then we get ft2 over ft1, plug in your frequencies, 200 Hertz over 206 Hertz squared. Your units cancel, and you're left with 0.943, and that's after you square it. So ft2 over ft1 is equal to 0.943, or written another way, ft2 is equal to 0.943 ft1. Okay, so here's the thing. The final frequency, ft2, should only be 94.3% of the first frequency. In other words, the change that we have to do is make it 1 minus 0.943, which is 0.057 or 5.7% less. Okay? Again, the final frequency, ft2, should only be 0.943 or 94%, 0.3% of the first one, or 5.7% less. Okay, so we have to decrease by 5.7%. And that's it for this video, guys. I hope you enjoyed it. If you have any questions, be sure to leave them in the comment section below. Otherwise, be sure to subscribe to Physics in the Flesh. Stay tuned next week for video 143 to be posted at 12 noon. What? Wait, who's back to school? Pumpkin pie recipe. Okay, I'll save that for Halloween. Guys, so that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me, which, by the way, I post every weekday at 12 noon. So be sure to be on my channel at that time. As always, if you missed my videos from the past, be sure to click over there on the right. You'll see some of my latest videos there. And other than that, guys, I hope you enjoy the rest of your day. Peace.